So in order to plan this lesson, I first had to start with my exit ticket and my objective. So right now I'm in the equations and expressions unit. I looked at what I did the day before, which was we looked at substituting in numbers for variables. Today I wanted to take it a step further. Students are trying to decide whether or not equations are equivalent. So one way that they did it was with substitution, and then today they needed to combine the like terms. So in order to start the lesson, I first got the objective, then I got my exit ticket questions, which were 5 questions. Those exit ticket questions let me know what it is that the students needed to be able to do by the end of my lesson. I first started with Illuminate, and then I moved to exittick.org because I wanted to create some of my own questions, and I find that exittick.org is a little bit more user-friendly, and I can adapt it to students a little bit easier. I can reroute the questions, drag and drop. I can also add different pictures in there, and students get more eager, and they're excited to use exittick.org.com more than Illuminate. So today what I'm going to do is have the students who are lower level, they're going to go ahead and start watching a Learn Zillion video before they even take any type of assessment. Coming into this lesson based off yesterday's exit ticket and just their overall level, I know that they're going to struggle, and I would rather them get the lesson from me and then hear it again from another teacher, which is the platform Learn Zillion, which has another teacher explain the steps, gives them visuals and models, and they basically take notes a second time. So I tend to do small groups at least 3 times a week in my class. I already have an idea of who my students who need more support are, so I start the beginning of class already in that seating format. So my students who are higher level, I already know who they are. They generally consistently score proficient or advanced on homework and on skills assessments. Today I'm going to have those students already seated in the back, and those are their assigned seats anyway. What they're going to do is work together to work on a worksheet, and then once they finish that worksheet and show me that they know how to do it, I'm going to have them work on Waggle to just further their knowledge and other skills that they're going to need help on later in the unit. So the way that I identify scholars that need to be pulled are just based off their level in everyday exit tickets that I've given throughout the week. With today being a Wednesday, I've already taught lessons that are building up to what we're doing today, so I already know who is struggling. Based off that, I put students in groups, and they sit there throughout the week, 1 to 2 weeks, and if I need adjustments, I'll have certain students move, but for the most part, students are placed permanently in these cooperative learning groups. An exit ticket is going to be a form of assessment that a teacher can use to know whether or not their lesson was effective. Generally, with my exit tickets, I start from an easy question. If the student was paying attention and they got a basic grasp of what I taught, they'll be able to get the first 2 questions right. I then move on gradually and kind of scaffold the lesson. The last question will be more of a challenge question. If a student was able to complete all of the exit ticket questions and get it right, that lets me know that they mastered the standard and they have a good understanding of what it is that I taught today. Therefore, when they go to the homework, they'll be able to be successful on that. The students who aren't successful on the exit ticket, generally before they leave or in small groups, I use the exit tickets to work with them because I already know their shortcomings before I send them to work on material by themselves. Exit ticket also allows me to measure growth. So tomorrow I might have them take that same test again, or I might do it later in the week just to see if they made any improvement. Today, the standard that I'm teaching is EE4, which stands for Equations and Expressions. The goal of today's lesson is for students to combine like terms. If I give them y plus y plus y, they need to know that that's going to be equivalent to 3y. In order for them to do that, they need to know the vocabulary words. They need to know what a variable is, what a coefficient, and what a constant is. Once they have an understanding of that, they can then organize and rewrite the terms that are like together, and then the final step will be for them to combine them. So this is going to be my first period class, LMU, my homeroom. Generally with my first lesson, I kind of go for what I know and then I tweak it throughout the second, third, and fourth period. I know that students already have an understanding of the basic vocabulary and they know what equivalent means, and they've used substitution to plug in a number for the variable. So today, combining like terms is going to be something new, but it's definitely related to what we've been working on all week. This lesson is a build off of lessons that we've done this week. Students first started off on learning the basic vocabulary, so they know what a variable, a coefficient, and a constant is. Yesterday, students used substitution to plug in a number to find whether or not two equations or expressions are equivalent. Now today, they're going to go ahead and combine them. What I found in the previous years is that sometimes students are so used to plugging in a number and substituting, and they want to get to one answer. Whereas with combining, your ultimate goal is not to get one answer, it's to get as few terms as possible. So you just want to reorder and organize the numbers that are like, but you don't necessarily want one number. This is going to be my first period class, so this is my first time teaching this lesson today. LMU is generally a split class, half and half. I have it where half of my students need extra support, and generally the other half can work independently or in small groups together. I'm looking forward to working with them and making lots of growth today. Do Now worksheet should be out as soon as I put up the projector. Your Do Now class is officially started, so right now I'm just giving you a chance to get ready, testing out this mic volume. Malik, you gotta stay focused today, okay? It's gonna be a chance where you work with your neighbor, but you gotta make sure that when I'm talking that you're not, because then when you're talking, I think you have a question or something, and then I look at you. We also wanna make sure we don't just get up and walk around. If you need something, a pencil, throw trash away, tissue, just use the signal and I'll let you know whether or not it's a good time. And we know when is an appropriate time to try to leave and when appropriate time is not. Please make sure you're on the back page. Today is Wednesday. You wanna start doing your 3 problems on the back in the Wednesday box. Please make sure that you start your silent daily 5. So some of us started straight on the Do Now, but the homework, we gotta write our homework first in our agenda. I know some of you guys did it during homeroom, so if you didn't, make sure you write down your homework. Let's change that, you're right. I thought you, what happened to it? Did you get the other one signed? And where is your agenda? Have you looked for it? Yes. Did you look at home? Is that your phone, Susanna? Mm-hmm. Have your homework. Keep going. You don't have to watch me. Do it like what? Mm-hmm. Sit right here. If you have not moved to numbers 2 or 3 yet, you want to move to numbers 2 and or 3. Then make sure that you box your final answers. what does the fraction mean? What's another operation for fraction? Division. So this is saying do 3 times x plus 1, and then whatever you get there, then divide that whole thing by 2. So if you set it up, I see you plugged it in, right? When a number is next to another number with the parentheses, what is that telling you to do?
Do that first.
But what operation are you supposed to use?
Division.
No. When a number is next to a variable, that's multiplication. So you would, and then that means 3 times 3. So you would do 3 times 3 and then do what?
Add 1.
Yep, and then the last step will be to divide by. Divide by what? 2. There you go. All right. Should be about 1 more minute on the timer. Yep. Where'd you get, Tiana? So you got 8x5. I know you weren't here that day, but here I said x means what? If x equals what? If x equals what? 3. So instead of putting an x right here, you really write a 3.
Oh.
Yeah. All right. Thank you. I had Julian's eyes on the first attention-getting signal. So I need 3 volunteers to come up to the board. Please show your work in an upside-down pyramid and box your final answers and be ready to explain. London, you can do number 1. All right. And then Tian, what number did I say you could do? 3. So who could do number 2 for me? Let's go ahead, Ajay. And then table monitors, go ahead and grade do nows. For those of you who are already done with your do now, make sure you review your homework. I am going to take like 2 questions. I know that some people had a question with that top problem on the back page, so that's probably going to be one of them that I go over, but identify another question that you have. Malik, just check to see for completion. You don't have to look for the right and wrong answers. As long as they did all 3 problems, then they get 3 points. Angel, you should have out your homework because we're about to go over it. Thank you, Rasan. Who's the table monitor here? Anthony. Oh, you just passed it to him? That's a good idea. I don't know. I'm going to ask the class. All right. In 1 minute, be ready to go over the do now and grade your homework. I'm going to do the group things. I already kind of have them situated in the groups that I'm going to work with. So, yeah, so these are like the priority. Well, those 2 are like the priority, and then I was going to have them start off with the video. So I could take them, and you could take them, and then if we have time. Sweetie, you're already done. Huh? No.
I don't know if this one's because I counted by 10.
So 8 times x plus 5. X is, what did I say x is? What does it say if x equals?
8.
No, the first line. If x equals. London, I gotta move on, sweetie. So if x, what does the first sentence say? If x equals.
Y. No, it's x equals 3.
What does that say? So right here you put a 3, and then you add 5. 8 times 3 is 20. 24, and then you add 24 plus 5, which is 'There you go. So I need you to make sure you use a pencil and then write it the correct way, because I think you weren't here that day. So that was the lesson called substitution. That's it. Have a seat. Thank you. I need the top. All right. 1, 2, 3. Eyes on me.
1, 2, eyes on me.
I noticed that Anthony's table, he just had them pass him the do nows. Let's try that tomorrow so that the table monitors don't have to get up. You can just pass your do now to the table monitor. They can grade it with the red pen and then pass it back to you. And then understand that on Friday, I still collect them and I still review them. So your scores aren't final. I still have to go back and make sure that it was graded accurately. So thank you for my 3 volunteers who came up. Let's go ahead and review substitution. Can somebody remind me of what the theme line, what those commercials were about when I taught you about the substitution, Anthony? Plug it in, like the Glade commercials. Cool. So we learned that when I tell you what X is, or it can be any letter for a variable, the variable really stands for a what? For a number. The class, the variable stands for a what? Number. For a number. So here I told you that X represents what number? 3. So here where you see an X, it's no longer X. It's really a what? 3. Same thing for this X, and that X. So London solved number 1. London, what was your final answer? 29. 2 claps on 3. 1, 2, 3. You want to make sure that when you have a number in a parentheses and another number, that is an operation multiplication. When we were in elementary, they used the X, but now that we're in algebra, we don't use X anymore because that could be mistaken for a variable. Go ahead and explain number 2. Good job. 2 claps on 3. 1, 2, 3. So I like that Ajay did not do any mental math. Each row she showed me where she simplified, and her answer went down to an upside-down pyramid. Again, each time you solve these type of problems, this is combining order of operations and substitution together. So these are the exact steps that I need to see. And then lastly, finish this off with number 3, Tian.
So the X means 3. So 3 times 3 is 9, and 9 plus 1 is 10. So since it's over 2, we have to divide 10 by 2, which is 5. The answer is 5.
Good job. Final answer is 5. 2 claps on 3. 1, 2, 3. All right, let's take 2 minutes to review homework, and I am going to be collecting it. And then after that, we will be moving on to notes. So you want to make sure that your math notebook is out so that you don't have to stop and get anything out of your backpack. If you have any questions, please let me know by raising your hand, and I will be happy to answer any of them. What did I do with the homework? Oh, I have to pull it up. Yes. I'm not checking homework, London. I'm going over it. All right. Thanks for asking, though. Do you have yours out? Okay, cool. So I got a lot of questions during homeroom about problem number 3 on the back. Raise your hand if you had a question about problem number 3. All right, so I'm going to set the timer for 2 minutes. I'm going to try to do this in like 30 seconds. That way I can take at least one more question. So some of us are like, I don't get number 3. I don't know how to do number 3. Normally, I hear those type of responses when it requires you to read. We all know how to read, and we all are good at reading, so we want to make sure that when something asks us to read, that we don't just use the excuse, I don't know how to do it, that we actually read it, that we annotate. I put annotate on our homework 2 days ago, and you were like, what is annotate? Well, the same way that in ELA, when you read a paragraph, you're writing on the side, you're underlining keywords, you're writing questions. It works and it applies in math the same way. So this said, while walking past Miss Adams' classroom, Mr. Madrid saw these 2 expressions on the whiteboard. Can somebody read the first expression off your paper? What does it say, Tian?
2 less than 3 times the number H.
Perfect. So 3 times the number H can be represented like this. And then we need 2 less than. Generally, subtraction is going to be at the end of an expression because it's being taken away from something. You're not going to put subtraction at the beginning because if you put it at the beginning, you can't take it away from something. So it's 3H minus 2. And then the second one says 3 less than 2 times the number H. So 2 times H. And then it says 3 less than that. So first step, before you can solve any of the problems, you first had to read this sentence and then know that these were two expressions that were in words that you need to translate. Everybody say translate. So when I first taught you about translation, I showed you this crazy code and it had like mailboxes and horoscopes. And I told you that sometimes in math, we have to translate words into math expressions. Next, yesterday, we talked about whether something is equivalent. Who can remind me of what the word equivalent means? What does equivalent mean? So everybody knows what it means. I only see 6 hands up, so that's a simple question. I'll wait while you remember, or if you forgot, you look back in your notes, but we don't just get to sit there. Matthew, what's equivalent?
Equal to or the same.
Perfect. Equal to or the same. Thank you. So it says, show whether or not these two are equivalent. Show your work in the space below using a table like you were doing in the previous problems. And then it says, explain your answer. So go ahead and flip to the front. For problems number 1 and 2, did we use a table?
Yes.
So for those of you who said, I don't get it, well, I made it clear. I told you step by step what to do. So all you need to do is make a table, 3h minus 2, and then 2h minus 3, and then you pick a number to substitute in. Can somebody raise their hand and tell me what number they plugged in, both expressions, and what answers did you get? Malik, what answers did you get, and what did you plug in?
I plugged in the number 2 and I got 1 for 2 times 2 and I got, for 2 times.
What was the final answer for this side and the final answer for that side?
Final answer for the left side was 4.
Mm-hmm.
Final answer for the right side was 1.
1. Did anybody else plug in another number other than 2? Other than 2. Ajay, what number did you plug in? 1. Perfect. That's exactly what we did in the examples in our classwork. So a lot of the times I'm not tricking you with homework. We did 4 examples for classwork. I gave you 2 examples at the front of the homework, and then on the back I just wanted you to make your own chart. So it wasn't anything new. It just required you to do a little bit more. So Ajay, when you plugged in 1, what did you get on this side and what did you get on that side? You got 5 for both sides. All right. So can somebody tell me what happened when we seen this happen yesterday? Because yesterday we plugged in 3 numbers. Sometimes this happened where we did get the same equivalent number, and sometimes we didn't. What does that mean? Tian, what are you thinking?
No, I was thinking most of the time if we use 1 or 0, we'll end up with the same, but if we use a different number, we might come up with a different answer.
Right, so Tian remembers that yesterday when we plugged in 0 or 1, sometimes we still got equivalent expressions. But then when we picked another number like 2 or 5, sometimes it would still be the same, but sometimes it was different. Yesterday there was a sentence that we had to read, and it said, no matter what the variable is, if an equation is equivalent, then your answers will always be the same. Not only when you plug in 1, but when you plug in 2, if you plug in 7, if you plug in 8, it should still give you the same expression. You have a question, Malik? Mm-hmm.
How did you get to 5? Because if you plug in the 1.
So Ajay did this one, so if you want to give her some constructive criticism, we could ask her.
How did you get 5? Because 3 times 1 equals 3, and then 3 minus 2 equals 1. So I would presume that you would get 1.
See your mistake? So Malik is saying that when you plug in 1 here, 3 times 1 is 3. And then when you subtract 2, 3 minus 2 is 1. And then when you plug in 1 here, you get 2 times 1, which is 2. And then if you were to subtract 3, you would get a negative number. So Malik, what conclusion did you come up with when you plugged in yours? Is it equivalent or is it not equivalent? It's not equivalent. And then down here where it asks you to explain it in complete sentences, just like the exit ticket where I had you explain it, you would put these expressions are not equivalent. When I plugged in h equals 2, I got 4 and I got 1. That would be a perfect response for that problem. Tian? Okay. All right. So go ahead and update that because I know a lot of you guys had a lot of questions about that. And then we're going to go ahead and move on. Also, feel free to call me if you guys get stuck on homework because for homeroom time, we only have like 20 minutes. And sometimes I'm helping you with your morning work. You're finishing up for other classes. So don't wait until class to ask me about the math homework. You could come by after school. You guys have math first period, so we could work on our homework at lunch. Go ahead and take 10 seconds to update that. And then I want you to go ahead and pass up your math homework. It normally takes us 30 seconds to pass up our homework, so I'll set the timer for 1 minute. And before the 1 minute is over, I should have all homework assignments sitting here, and people should be updating their table of contents. Thank you. Thank you. There you go. Anthony, give it to her so that you only make one pass, remember? There we go. Perfect. All right, do I have all homeworks? It's 30 seconds on the clock, so normally we have it done in 30 seconds. We want to make sure that we stick to our time. If we did it once, then we need to stick with it. Perfect. So we have 15 seconds left on the clock, so that means it took us 45 seconds. So tomorrow when we pass up the homework, I want to make sure we get back down to 30. Today our topic is combining like terms, or to combine like terms. So what you want to do is go ahead and take out your math notebook. You want to update your table of contents, and then you want to go to the very next open page and update your heading. I see that Anthony is already ready. He had his notebook out during the do now. All right. So, can you guys put the things that I passed out back in the middle of the table? I'll let you know when to get them. Right now we're focusing on notes, and then we'll move on to the worksheet. So leave them in the middle of the table where I placed them. Thank you. Okay. I'm waiting on about 3 students. I still see people moving. I'll know that you're ready to hear me because you're looking, you're slanting. Thank you, Dennis. Thank you, Ajay. Thank you, Rhonda. Thank you, Anthony. Okay, cool. So here's our objective today. Go ahead and look at it, read it to yourself. Everybody say algebraic. Algebraic. That's that word that some of us get tripped up on when we have to pronounce it. So let's go ahead and read this together, starting with students will be able to. 1, 2, 3.
Students will be able to combine like terms in algebraic expressions.
Great. So before we learn how to combine like terms, we know that an algebraic expression has numbers and it has variables. We're moving on to algebra now. We also know that terms are like words. So anytime something is separated by a plus or a minus sign or a division sign, those can be broken down into separate words or separate parts. Today what we're going to do is we're going to put the parts that are alike together and combine it and make it a little bit smaller. So in order to do that, I want to review some of those key vocabulary words. So I picked like terms, coefficient. Everybody say coefficient. 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 Constant. And then if we see the word simplified, that's another word for solve or for evaluate or for combine. So go ahead and take 2 to 3 minutes to write down these 4 vocabulary words and then be prepared to do 3 examples. Let's go to Malik and put your backpack on the back of the seat. Thank you. So Rhonda is on constant. Ajay is also on constant. Brindy is finished, so she's going to reread over her notes to make sure that she understands what those definitions mean. On the next slide, I'm going to have you identify the constant, tell me what the coefficient is, tell me how many terms, because again, we did this last week, so this is just a quick review. This is going to help us be successful at combining the different terms today. Julian is almost at simplified. I see some nice, neat notes. You want to make sure that you can understand them because you need to refer back to these when you're doing your homework or studying for a test. All right, Brandon is ready, so is Angel, so is Rhonda. Take about 10 more seconds. Sometimes it's hard to listen and write at the same time, so when most people are done, I'm going to go ahead and start reviewing, and then the people who need the last sentence can finish. I added or combine down here. If you didn't see it, I didn't type it, I just wanted to add it there. Simplified or combine. Did you add or combine, Brindia? Good. Let me have a volunteer read like terms. What does like terms mean if a term is like? Go ahead, Wachi. Thank you. I'm sorry, I don't mean to pause you, but can you speak up so that people in the front can hear you? And who are we tracking? Who are we supporting right now? Wachi. Perfect. Perfect. So like terms, a term is going to be something that's separated by a plus or a minus sign, but a like term means that they're going to have the same variable. So today we're going to be combining the x's with the x's. If there's a variable that's a t, we're going to be putting the t's with the t's. If there are variables with exponents, we're going to combine the other variables that have exponents. Thank you, Wachi. Go ahead and read coefficient for me. Anthony?
The number in front of the variable. Example, 5 in squared minus 5 is the coefficient.
Perfect. So the coefficient, does anybody remember what the analogy that I used about flying to help you remember what coefficient is? Anybody remember? Say it, Rhonda? Don't be making me feel like I didn't teach y'all that. What is it? I know I talked about it. The co-pilot. So the co-pilot is going to be in the cabin with the pilot. The coefficient is going to be attached to the variable. So in this case, the 5 is attached to the n. It's its partner, and that's going to be considered the coefficient. The constant, let's go ahead and read constant together on the count of 3. 1, 2, 3. Perfect. So at the end of an expression, if you see plus 2 or minus 3, that's going to be a number that's not going to change. It does not have a variable. It does not have a coefficient with it. It is the constant. It's going to remain the same. And then today, when you see the word simplify or combine, who can read what it is that it's telling you to do when you're simplifying or combining? Thank you, Michelle. Go ahead. Perfect. So when all terms that are alike have been put together. So before we move on, here's an expression. It says 4x plus what? 4x plus 2. So the 4 is the coefficient, the x is the variable, and the constant is the number what? 2. Perfect. So I'm going to show you another one. And before we move on with your neighbor, I want you to identify the coefficient, the variable, and the constant. Here's the problem. Go ahead and look at it for 10 seconds. Go ahead and turn to your neighbor. And then I need you to identify the constant, the coefficient, and the variable. Go. Just talk about it. What is it, Mombasa? 5, 4, 3, 2, 1, 0. All right, what is the variable? X. Variable is a letter that really represents a number. Which one is the constant? Which one is the constant, the number that's alone? Somebody look back in your notes and read what constant is real quick. What does constant say in your notes, Brendia?
Number is not attached to a variable.
Right, so if you got confused, you could have just quickly looked in your notes. That's why you take notes. We have to be more comfortable with looking back at our notes. So 27 is the number that's alone, and then what's the coefficient? 2. So the difference between this problem and this problem is just that I changed the order. So the order does not matter. You want to look for the variable that's attached to the number, and you want to look for the number that's by itself. Get it? All right, so I didn't have 100% with that. So before I move on to actually combining like terms, I'm going to give you one more of these problems, and I need you to be able to identify the constant, the coefficient, and the what? And the variable. All right, and this one is going to be a challenge. It's going to be a little bit, I added something to it. All right, go ahead and go. Talk to Brandon. There can be more than one coefficient. You got to write it down? Go ahead. Julian, what are the variables? X, so 2 x's. What's one of the coefficients, Malik? Good, thanks for looking at your notes. Wait, you said what? 2, okay. Take 10 more seconds. My only hint is that there are 2 coefficients. 5, 4, 3, 2, 1, and 0. Thank you for giving me 100% when I got to 0. Let's start with the variables. There's only one letter. What is the variable, class? X. Who can explain what the 2 coefficients are? Susanna, thank you. So the coefficient is the number in front of the variable, the 2, and the 27, good. So the 27 and the 2 are the coefficients because they have a partner, just like a co-pilot has a partner. And then what's that lonely number? What is it, Mombasa? And what is it called? What's the vocabulary word for it? Let's send him some. Constant, good. So I noticed that some students, when I said turn to your partner, they had their notes and they were like, no, the constant is the one by itself. Use your notes. This is your math notebook. This is your book. This is where all of your answers are going to be. All right. So here are 3 rules that we're going to be using today. It says to simplify in expressions, you can combine coefficients with coefficients, and then you can combine constants with constants. So go ahead and write this in your notes. You can write it on the right-hand side. And then we're going to do 3 examples. What happened?
She said it's loud over there, and I told her I couldn't concentrate. She said to come back here.
Sorry, excuse me, sweetie. Can you put that away? Scoot up, Angel. Scoot in, Matthew. Scoot in so you can be comfortable. Anthony, scoot over a little bit. Scoot over a little bit. You don't know more? All right, let's go ahead and get started with our first example. And on the next slide, these 3 steps are going to be on the slide. You don't need to rewrite it. You're just going to rewrite the problem. I just want the steps to be there so that we can see what we need to do. All right, so I'm going to go ahead and move on. The steps are still up there if you didn't get it, but we're going to go ahead and move on to the problem. So here's the first problem. Go ahead and write this on the left-hand side. It says 14x plus 2x plus 15 plus 12x. All right. So first, to simplify an expression, you can combine the coefficients with the coefficients, and then you want to make sure that you combine the constants with the constants that are the same. So when we look at terms, this has 4 different terms, 1, 2, 3, 4. Terms are like words in a sentence. It's how many different parts to an expression. Generally, the parts are separated by a plus or a minus sign. So how many terms do you see here? 4. Great. So I also color-coded it for you. What you should notice, excuse me, oopsie. So what we'll notice is that the 12, the 2, and the 14 are all red, and they all have what is a variable? X. So in this case, we want to combine the coefficients that have the same variable of x. So I'm going to rewrite this, and I'm going to write 14, 2, and 12 by each other. 14x plus 2x plus 12x. And then I have plus 15 at the end. So you want to go ahead and write that? On the right side is fine. So in the step that I just did, I just put the terms that all had the x as a variable together. And then the 15 was the only one that didn't have it, so I just put the 15 at the end. Okay. Next, I want to combine the coefficients that have the same variable. So I'm going to add 14 plus 2 plus 12. All right. And again, I don't like to get problems wrong that I know how to do. So I wouldn't even do mental math on the side. I'm going to go ahead and show my work, which you should feel comfortable doing. All right. When I added 14 plus 2 plus 12, I got 14, 12, and then I put the 2 at the bottom. I got what? 28. So what's going to happen is that these terms, when I put them all together, they're going to be combined to 28x. The original x from the variable still stays with the problem. We just combine the coefficients because they are like terms. And then I have this 15, which is the constant that just is going to stay there. I'm going to box this as my final answer, and I'll tell you why in just a second. Make sure that you show your work on the side just how I show my work, because sometimes we're getting these problems wrong. We follow each and every step, but we make a small mistake with the math. So show me how you added 14, 12, and 2, because sometimes it might be larger numbers, sometimes it might be exponents, and you might not always be able to do mental math, so don't rely on that. All right. So the reason why I boxed the final answer, the reason why I cannot combine anymore is because the 15 is a constant. It doesn't have a variable. All 3 of these terms all had a coefficient in the same variable, so I was able to put those together and combine them. I cannot add the 28 with the 15 because the 15 does not have a what is a variable? It does not have an x. So this is the simplified version of this, where I combine the terms that had the same variable. I combine the coefficients, okay? So let's go ahead and try another example. Example number 2 looks like this. Oh, and the answer is there. So go ahead and write example number 2. Oops. Okay, so I see people writing on the left-hand side. And then I want you to go ahead and term with your neighbor, and I want you to identify the terms that are alike. In order for the terms to be alike, they have to have the same variable. and then what other terms are alike. And then I want you to go ahead and combine them like we just did in example number 1. So what are you thinking, Michelle?
I said that 15 and 24 are opposite.
So, yep.
4 are a
Okay, so if we combine them, what 2 numbers do we add together? What 2 numbers? You said that those are the constants, so they're the ones that are alone. So what do we do with those 2 numbers? We add them. We combine them together. And then what do we do with those 2? What did I just say for here? If we combine, there we go. All right, 1, 2, 3, eyes on me. 1, 2, eyes on you. All right, so this is also color coordinated just like the other problem. The 6 both have a variable of what? X. And then these constants don't have any variable, but they're still like terms because they're just numbers. So the first 2 numbers that I need to combine is the 6 with the what?
4.
With the 4. 6 plus 4 is going to be? 10. Same thing here. The next step is going to be to combine the 15 and the 24 because they are like terms. They're just numbers. And our final answer is going to be 10x plus 39. Can somebody tell me why this is the final answer? Because some people who weren't here today might tomorrow come and might do this. They'll go 39 plus 10. Oh, they'll go 49x. Why does that not work, Malik?
Because 39 doesn't have a variable.
39 doesn't have a variable. What's the vocabulary word for a number without a variable? A constant. So 39 is the constant, whereas 10 is the coefficient. So constants and coefficients cannot be combined. Thank you. All right, let's go ahead and do one last example. And again, I'm stepping it up a notch before we move on to our different groups. Go ahead and write this. And then there's a hint down here that I want you to write before you start solving it. Mm-hmm. I just want you to write it. We'll solve it together. So write it and write the hint. Got it. Okay, who can read the hint? Dennis, actually, I want you to read the hint for me. What does the hint say at the bottom?
If a variable appears by itself, it is a 1 as a coefficient.
It has a 1 as a coefficient. So right smack dab in the middle, you see an x by itself. You could go ahead and add your imaginary 1 there. It's an imaginary 1. So I see 2 different variables. What 2 variables do you see here, Mildred? What variables do you see in this expression? X and Y. Perfect. So Mildred identified that the 2 variables are X and Y. So first things first is I want to combine the terms that are like, I see 3X. What other term is like 3X? 1X and what else? 1X and 6X. So we looked for the terms that had the same variable, and then we just combined the coefficients. So let's go ahead and do that. What is 6 plus 1 plus 3? Say it in your, think about it in your head. You could do mental math. And what's the answer? 10. So the coefficient is 10, but the variable still remains what? 10x. Good. Next, I'm going to look at my constants. I see 2 constants. I see an 11, and what's the other constant? 2. So I'm going to combine the 11 and the 2 together. What's 11 plus 2?
13.
11, 12, and 13. So it's just going to be 13. And then lastly, I have this 4y. Are there any other terms that have a y? No. So there's nothing to combine it with. It's by itself. So the final answer is going to be 10x plus 13 plus 4y. And some people might ask about the order. You can change the order. So if you want to write the variables first, like 10x plus 4y plus 13, then that's fine too. The order with addition doesn't matter if you change the order. All right? Okay. So what I want to do now is I want you to go ahead and put your notebook to the side. Everybody say exittick.com. Exittick.com. So Remember, it's not Illuminate. I don't want to get anybody in Illuminate like it's not here. There's no assessments. Where are we logging into? Okay. When I say go, I want you to log into exittick.com. There's going to be a quiz there waiting for you, and it's going to be called Combining Like Terms. What I want you to do is to go ahead and take that exit ticket, and then when you're finished, you can tilt your computer to a 30-degree angle and wait for further instructions. We are going to be moving on to groups, and so if I come and tap you and tell you to do something else, just quietly do that. Brendia, what questions do you have before we get started? Okay, I'll get those to you. Any other questions? All right, go ahead and grab your computer and log in. I know. You can get up, sweetie. Don't lean. That's not safe. Can you get Mombasa one as well? Thank you. I'm going to have them start on the video, I think. Right here? Yeah. Okay, pencil. I just said log in to exittick.org. That's all I asked you to do. Okay. So I'm looking forward to seeing students at the Bluff get logged in. So right now, I want you guys to send during anything online. Silent, so you shouldn't be talking. If you have a question, let me know. Okay. Oh, she's gonna get you a computer. What was wrong with this one? What's wrong with it? So did you put it back? So if we have dead computers, we want to charge them because they're going to stay dead. Nobody will ever be able to use it. Try it, Omar. I think it says that it's fully charged. Thank you. What's the problem? Are you clicking on it like that? Got it? It's going slow. If it ever does that, just restart it, okay, Omar? Because you said it was dead, but it was fully charged. Hmm?
It's not working. Can you set change my password?
Why doesn't it have where you can log in using your Gmail? Okay, go ahead and submit. All right. I went ahead and logged out the students that didn't submit yet because the instructions were to close your computer. So take 10 seconds to go ahead and close your computer. Face me, and I'll let you know what's next. You have 10, you have 9, 8, 7, 6, 5, 4. Get the worksheet out in front of you. 3, 2, 1, and 0. All right, I see that Malik has the worksheet in front of him. I see that Tian and Brandon are ready to move on to the next part. Hold on to them for me. All right, so I want you guys to go ahead and this is some classwork right here. And I want you to just work with your neighbor to go ahead and finish this worksheet only. And then I want you to move to Waggle when you get finished, okay? The front and the back, yep. How about we do the front with our partner and then we do the back by ourselves, okay? So I'm gonna be working with the groups in the front, so I expect that you guys can use each other. Only come to me or Miss Patel if it's an emergency, okay? And then I'll know that you finished the front and the back because you'll be working on what? Waggle, thank you. All right, I'm gonna come and work with you guys in a little bit. So put this to the side and then we're gonna do this together. While I work with that group, I want you guys to work on this worksheet. Just work on the front with your neighbor. By the time you finish the front, I should be done with them and then I'll come over and then do this front part with you guys, okay? I'm gonna start with them. I'm gonna just have them finish watching that video. I don't know if they're gonna be done soon. If you wanna, I would just say work with them, but you can start with them until they get finished. Okay, cool. All right, so we're gonna work on these guided notes that we're gonna be putting in our notebook at the end of class. So go ahead and have this in front of you. And then it says the students are going to be able to combine like terms regardless of the variable. Go ahead and write the word variable there. We're going to have to move fast. We only have about 5 or 6 minutes in a small group. So I want to make sure that you guys get to ask any questions and I need your full attention, okay? Okay? Okay. Got it? All right. So it says students will be able to combine like terms regardless of the variable. And it says that regardless of the variables that are in algebraic equation. So in algebraic expressions and equations, variables can be thought of as a coefficients what? So read the sentence, exactly. So read the sentence to yourself. I'm not going to read it for you. It says, in an algebraic expression or equation, it says variables can be thought of as a coefficients, what? Last name. So coefficients cannot go together unless they have the same what? Same last name. It wouldn't be variable name, guys. Come on, wake up. Y'all ready to work? Or should I start with the other table first? Y'all ready? So when I'm talking, I shouldn't just be talking to Tian. I'm working with the whole table, so I need you guys to interact. And if you don't get it, say, I'm not sure. Can you explain it again? Can you repeat it again? But you can't just stare at me like that, okay? All right. So it says, before combining like terms, always circle the number that goes first. So x's can be combined with x's. So let's go ahead and circle the 3 and the 4. So in the 3 and the 4, we are going to combine them because the operation is addition. So what's 3 plus 4? 7. So 7 will be the first name, and then what is the last name, the coefficients that they both have? X. All right. Okay. So look at this example. What does this say? 3x. 2. How do we say exponents, guys? Squared. So we say 3x squared plus 5x squared. So let's say this again. This says 3x squared. So how do we say this whole expression? Let's go ahead and say it. Go. Go ahead and circle the coefficients, the numbers in front. What 2 numbers did we just circle? 3 and 5. Go ahead and underline the last name, which is x squared. So let's go ahead and combine the 3 and the 5 by using addition. What is 3 plus 5? And we get a what? 8x squared. So the first name is what's being combined, but the last name, which is the variable, is what's going to stay the same. So when you add 3x squared plus 5x squared, you get 8x squared. Tion? Why we didn't do the exponent? You just don't do the exponent because when you add exponents, there are different rules for adding and multiplying exponents. So we would actually multiply the exponents together, but the lesson isn't on exponents. It's just combining like terms. I think in 7th grade, that's one of the standards where you learn how to add exponents, multiply, and divide, but it's totally separate rules. Good question. So it says go ahead and combine these terms. It says the y's and the x's cannot be combined. So let's go ahead and put circles around the y's. And let's put squares around the x's. All right, Angel. So what 2 numbers did we just circle, Angel? Quickly, Angel.
X and Y.
Angel, we just circled the two terms that are alike because they have the same variable. Which 2 numbers did I put a circle around?
5 and 8.
5 and 8. It's telling me to add, so I need to write 5y plus 5y. 5y, I'm sorry, 5y plus 8y. And then, Brandon, what are the other 2 terms that are alike that we put boxes around?
No matter what, the variable has a imaginary one.
Okay, what did he just say, Michelle, about? One. So not that it needs an invisible one, Michelle, but when we see a variable with no number, it has an imaginary 1 in front of it. So when we rewrite this, Michelle, I'm going to write 2x plus what? Because I'm putting the x's by each other now. I'm going to put what? Imaginary 1. So what do I write, Michelle? 1x. Great. So now I need to combine them together. So Rhonda, I need to add 8 plus 5. What is 8 plus 5? 13. And then what's the last name, or what's the variable? 13y plus, and then 2, Michelle, and then your imaginary 1, what would that be? 3 what? 3x. Good job. So what I want you to do is I want you to work on this problem and this problem with your neighbor, and then I'm going to come back and check with you. Yes, you put an addition sign in between the terms. All right. This one and this one. The next 2. I need you to finish those 2 problems. All right. Should we go check in with them? Hello, how's it going with your video? All right, go ahead and pause your video. Excuse me, Susanna, go ahead and pause your video. Pause it. Tilt your computer to a 45-degree angle. I want to go over this worksheet with you really quick. Okay. All right, who can tell me what the video was about? Summarize it for me in a couple sentences. Tiana, who are we tracking right now? I'll know that you're tracking Tiana because your headphones will be off and you'll be looking at her. So what did you gather from the video? What was the video trying to teach you?
The video,
Speak louder.
this lesson is about how do you simplify, how you say that word again?
Algebraic.
Algebraic expressions.
Okay, so that's what.
By combining like terms.
Okay, perfect. So go ahead and get this worksheet in front of you. I want to do a couple of combining like terms problems with you. Hopefully the video, I know the video had some modeling. Okay, I know the video had some modeling. Can somebody tell me what it was talking about with the different blocks that it showed you? Because I seen the video. Well, why was it using the blocks, or what was the block? What were the blocks used to show?
Well, these,
London, what were you gonna say?
they were used to help you. They were used to help you equivalent to find out how they got 3x plus 13.
So that what they did is the terms that were alike, they had separate blocks, right? So some of the blocks were green, some of the blocks were blue, some of the blocks were little cubes. So what it wanted to do is it wanted to separate the different letters with the letters and the different numbers with the numbers. So go ahead and look at this a problem right here where it says 5y plus 2x plus 8y. All right, and I want you to circle all of the I want you to circle the 5y. And then I want you to circle the other term that also has a y in it. Monica, what else did you circle?
8y.
8y. So because those both have a y, that means that they're the same. Everybody say the same. So we're going to write those two by each other. So go ahead and write 5y plus 8y next to each other. Okay. All right. And then go ahead and put a box around the other two terms with the x's. All right. What two things did you put a box around, Tiana? The 2x and the
5y plus 8y.
in the x. So London, we put the circles around the y's and we put the squares around the x. So we wrote 5y plus 8y. Now let's write 2x plus just x. Brendia, is everything okay? What are you supposed to be working on right now? Okay, can you please make sure that you and Kayla work together on F so that you can work through the problems before it's time to go? All right, so now we're going to add the 5y and the 8y together because they both have y's as variables. So 8 plus 5 is 13. So underneath that, I'm going to write 13y.
Underneath this, 5.
You can look right here too, London. That's why my paper's right here. 13y. And then 2x plus 1 is going to be 3x. Monica?
If they didn't have a letter,
Hand me a whiteboard.
if they didn't have a letter, you just put the problem, right? You just put the
So if it doesn't have a letter, you put an actual 1 in front of it. Omar, can you give me the pen out of that green thing right there? All right. So it would be 13y plus 3x. You see it now? All right, let's go ahead and do this next problem together. Actually, I want to do this long one where it says 7m. Go ahead and put circles around all of the other terms that have an m in it. Okay, London, which two, or I don't know if it's two, which ones did you circle? 7m and 2m. Go ahead and write those next to each other now. So 7m plus 2m. Okay. What other variables, Omar, do you see in this expression?
I see
A y and an n. Let's deal with the y's. Go ahead and put a box around the y's. Which two boxes do we put around, Omar?
3y and 8y.
3y and 8y. Okay, so let's write those next to each other. Okay. And then what's last, Mildred? We did the y's, we did the m's. What's next? 3n and 2n. So let's write those by each other. 3n and 2n. Okay. Are they ready? Well, I'll wrap it up. Okay. All right. So let's go ahead and add the 3 plus the 2 and get what's 7 plus 2, I'm sorry, is what? 7 plus 2 is,
9.
so let's write 9m. And then what's 3 plus 8?
What we write?
11 what?
11y.
Good job. And then what about the 3 plus the 2? 5. And what's the variable? 5n. Yep. So now we just combine all of the ones that are the same.
So now we just add it.
And you just leave it like that. Because the m is separate, it's an m, and the y is a y, and the n is an n, so they can't be put together. So you're done. So I want you guys to, it is time to go, but I want you to look at A and B before we go. See if you can do A and B. See if you can do A and B before we go.
How do we supposed to do it? Letters. How do we?
It's a 1 in front of it. So it's 1A, 2A, 3A. Got it? Okay. Thank you, Brandon, for your attention. Thank you, Dennis, for your attention. All right. If you're writing, please put your pencils down. Thank you. All right. So we do need to wrap class up. I'd like to thank the groups that worked independently, the groups that worked with their neighbors, and those people who were able to get information that they needed. What I want you to do now is to take the worksheets that you have, and I want you to put them in your class folder. I need you to have a seat. Have a seat. And put them in your class work folder.
When you finish it, can Is this for proof or will we just, or will we?
I just want you to leave it in your classwork folder, and then tomorrow we'll look at it.
So I'll do that tomorrow.
And then go ahead and place your red folders in the middle of the table.
Or what if we didn't finish the exit ticket?
You're going to put everything in your folder. I just said, please, put everything in your folder. Put everything in your folder. And then go ahead and stack your folders in the middle of the table and go ahead and pack up. Okay. I feel really good about how the lesson went today. I'm confident that students will be able to get more practice through their homework and come in tomorrow and demonstrate that they have mastery of the standard. I did use exittick.org in the middle of the lesson before I worked into my small groups. The results of the exit ticket were about 55% mastery. Not coincidentally, but the students who did score red or below basic were already placed in the cooperative learning groups, either with myself or working independently. So my next steps for that will be tomorrow. I will start the class with a very similar exit ticket. Now that students have got more practice and had the opportunity to work with me in small groups, I think that if they see the quiz again, that I will see the growth that I was hoping to see today. I did run out of time. When you work with small groups, it's very important to time everything. I did not use my timer at every aspect of the lesson, but I appreciated having Ms. Patel come in, and she was able to check in with the other small group. What I noticed is that the students who were working with me felt very comfortable and confident as they were working through the classwork. They were able to ask questions, whereas normally in class, sometimes they're unfocused, or I don't even have like eye contact with them. So what I'm expecting for tomorrow when they come in and take an entrance ticket, those kids who were able to get the small group instruction, I'm anticipating that their scores will definitely increase. So my next steps are going to be thinking about teaching my next 3 classes. I am going to allow the students in period 2 to take the exit ticket at the very end of class. I found that the students that were in small groups did need more time with me, so I'm not going to do the exit ticket as an interest ticket in the middle. Something else that I'm thinking about is tomorrow, when class starts, I'm going to use a few of these same questions in the do now just to reiterate some of the skills that I taught today. I'm going to give another entrance ticket that's very similar. It won't be as long. It'll maybe be 2 questions for me to get a basic understanding of who got it and who didn't. Those students who still have not mastered the standard, I will pull them aside more when we have small group instruction. I will also give them packets or papers just for them to get more practice on their own time.